Hello, this is my Lab 3 titled Black Hole for Physics 2211. So for this lab, our goal was to determine the mass of the black hole given the following initial conditions. So we are to assume the net force on the star is due solely to the black hole. The mass of the star is given, which is 2.0 times 10 to the 30th kilograms. Then the time step is 1 day, which we will convert to seconds, which is 86,400 seconds. Our initial position of the black hole is the origin. And for my results, I got that the mass of the black hole with a unique trajectory to my GT email was 1.79 times 10 to the 34th kilograms. So the physics principles used was the momentum principle, which is F net over the change in P over the change in time, and Newton's second law, which is F is equal to ma, and we have F net is equal to F parallel plus F perpendicular, and F parallel is equal to the magnitude of P over dt, and F perpendicular is equal to the magnitude of P over dP hat over dt. And next, we will also use Newton's universal law of gravitation, which states that two objects are attracted to each other by a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. So we can manipulate this formula to solve for mass of the black hole, which we can see through these equations. And here's just a diagram representing this formula. And next we'll take a look at the glow script code. So we have our gravitational constant. We have the mass of our star, which is 2e to the 30th power. We have delta t, which we have converted to seconds. And next we will look at the calculation loop. So for our initial and final position vectors, we can use p equals to mass times velocity to find those. And then to calculate the change in velocity and the change in momentum, we can use delta v is equal to v final minus v initial, and also delta p is equal to p final minus p initial. And for dp dt, we can just put our change in momentum over our change in time. For Newton's second law, we can do F net is equal to dp over dt. And to calculate dp dt parallel, we can use the formula given, the magnitude of p over dt, and then we can equal that to F net as well. And then also to find F perpendicular, we can just subtract F parallel from F net. And then we can use the formula that we saw for earlier and the universal gravitational constant formula. And then we just multiplied each force by the arrow scale. And now we will take a look at the code. As you can see, the blue vector is the parallel vector, the orange vector is the net force, and the pink vector that you can see is the perpendicular force. And next we will take a look at some lab questions. So we're asked to distinguish between the perpendicular and parallel. So we have our perpendicular net force and also the perpendicular rate of change of momentum. So for net force, it causes the star to change direction of motion, but the rate of change of momentum of perpendicular is the rate in which the star's direction of motion changes. And similarly, we can look at the parallel force. For net force, it causes the star's speed to change, and for the rate of change of momentum, the rate at which the star's speed changes, which is also the star's acceleration. So we are asked a what if question. So what if we remove the mass that we found and we put a different black hole into the same location? We can assume that the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? So, as we saw in our formula earlier, the only things that would cause a change in our mass found would be a change in the masses of the two objects, a change in the distance between the two objects, and a different gravitational constant. From the given conditions in the question, none of these three factors are changing, therefore there will be no difference if the black hole was removed. And here are a few more results. So we have the mass that I found by taking the average of all the values given by the glow script code. We have F net F net parallel, and F net perpendicular.